All right, well, let's go over the little activity that I had where you had to go to that website, the pHet website. There's a bunch of neat things on there if you want to go and like play with some of them. They're really interesting. Some of them are really heavy in physics and math, but they're kind of fun to like play with them and see what happens on some of these. So let's go through the first one, which happened to be all about net force. And you were supposed to turn on all of the indicators, so you should have had the sum of the forces, the values, and the speed all clicked up in your upper right-hand corner of the screen when you're playing with the little red and blue guys to make them pull on the tug-of-war back and forth. So the first question, I said, explore the program by placing a red and a blue figures on a rope to simulate a tug-of-war. Okay. Which figure can pull with the most force? Well, what you should have found was the big person can pull with the greatest amount of force. So that would have been the answer for number 1, letter A. Then we go to 1, letter B. What's the exact measurement of the force that each figure can pull the rope? So we got the small people, right, they can pull with 50 newtons of force, and that's actually the unit for force is newtons. And then what's a medium person pull with? 100 newtons, twice as much as a little person. And then we got the really large person, they pull with 150 newtons of force. Okay, make sure that you always put those units on there. Don't just say 50, 100, 150. You got to put the newtons after it. Question number 2. Now we're going to place 2 small blue figures on the left, and we're going to put 1 medium red figure on the right. So question letter A says, what's the resulting motion or speed? When you released them and had them do stuff, nothing happened. They just sat there and they're like, pulling it, and there's no motion of the rope, is there? So there's no motion or speed. So question letter B, what's the sum of the forces? What's the net force? It should have showed 0. All right, there was no net force. Question letter C, use a math equation to show how the net force was calculated. The blue side, you had 2 people over there. Each one, they were small, so it was 50 plus 50. That's 100, right? On the other side, you had 1 red person that was medium, and a red person exerts 100. So these 2 guys, 50 and 50, that's 100. And then they're pulling on another guy that's exerting 100. So we had 100 going this way and 100 going that way. Right? So what kind of letter D, are the forces balanced or unbalanced? Well, they're balanced. How do you know? Because you got 100 this way and 100 that way. Right? So it's a balanced force. And then also, we ended up with no motion. That's also a balanced force, like we talked in the idea of the notes before. All right, question number 3. Place 2 small blue figures on the left against 1 large red figure on the right. Right? So what is letter A? What is the resulting motion? Well, now all of a sudden it starts going towards the large person. It goes that direction, doesn't it? So it moves to the right. It says letter B, what is the sum of the forces? What's the net force? Well, these 2 small ones over here, they're exerting 50 and 50. That's 100. The big person on this side, he's exerting 150. So we got 100 this direction, we got 150 that direction. What's the net force? Well, we get 50 going in this direction. All right. Letter C, use a math equation to show how the net force was calculated. Well, that's what I just talked about. You got 50 plus 50, that's 100. And on this side, you got 150. So there's 100 going this direction and 150 going the other direction. Letter D, are the forces balanced or unbalanced? Well, this time they're unbalanced because we have 100 and 150. That's not equal, so that's why we all of a sudden get motion going in that direction. Flip the page, other side for me. Question number 4, what happens to the speed of the cart when one side is winning the tug of war? Well, this guy over here had more force, so what happened to the tug of war? Everything started going in that direction, right? So he ended up winning, so it moves in that direction. 4, letter A, is this type of motion considered acceleration? Did the speed change? They were both pulling initially this way and then the speed started going this direction, and there was also a change in direction. So yep, that is an acceleration. There was a change in speed, and also there was a change in direction. Question number 5. What happens to the speed of the cart when the tug of war is a tie? So the first one we had a tie. Well, what happened to the speed? 0. Okay, there was no change, there was no speed for that cart. All right, so 5, letter A, is this type of motion considered acceleration? No, when you're just sitting there, there's no change in speed, so it's not acceleration. All right, remember, if there's no change in speed, then it's not acceleration. Same thing can be happening as I'm cruising down the road going to Florida, and I set my cruise control, pink, at 70 miles an hour, and I'm going 70 miles an hour, and an hour from now I'm going 70 miles an hour, and another hour from now I'm going 70 miles an hour. Am I accelerating? Nope. My speed is not changing, so I'm not accelerating, even though I'm going 70 miles an hour, but I'm not changing my speed. If I have to speed up or I have to slow down, then I accelerated. I had a positive or a negative acceleration. All right, question number 6, we had somewhere we're supposed to fill in the blanks. Number 6, when two small figures are both pulling in the same direction, right, their individual forces are 50 plus 50, that's 100 together. So the answer is 100 together. Number 7, when two small figures are pulling in opposite directions, their individual forces, so we get 50 this way, 50 that way. Well, now it's balanced, right, because their forces equal 0. So it's balanced. Number 8, an unbalanced force results when the sum of all forces is unequal. When I have more force going one way than the other way, there's a little bit of force going the other way. So they're unequal, and that causes an object to accelerate in that direction, starts to go that direction. Last question, number 9, a balanced force results when the sum of all forces is equal. This is a balanced force if they're equal in both directions, right, and does not cause the object to accelerate. There's no change in speed, they just sit there and don't do anything. All right, so that concludes all the questions that went with that. Like I said, if you want to play with some of the other ones, that's great, all right, because I think they are kind of fun to mess with and see what happens.